Let's continue our exploration of analyzing data in which we have one categorical explanatory variable and a quantitative response variable, and we're doing this analysis using multiple regression. In fact, in the previous video, we looked at how we have predicted and residual values, just like we do when we have a quantitative explanatory variable and do multiple linear regression. What we have not done yet, however, is to actually create a regression model. So let's do that now. I'm going to go ahead and add a code chunk. And then let's add the command for building a regression model. We actually already built the regression model, so the command I need to enter here is for getting us a summary of that model. But you may recall that way back here near the beginning, here on line 40, was our command for building a linear regression model. So now let's go ahead and get a summary of that model so that we can get regression coefficients, and here they are. Well, there's a number of interesting things to note in this particular model. The first is that we have, for view, we have, in addition to the view variable, we have a grouping indicated for a variable. Here's one that says hierarchical list, and here's one that says egalitarian. So one thing that's new that we have not seen in the past when dealing with quantitative variables is that our single categorical explanatory variable was put into two parts. It was split into two parts. So rather than just having a view variable, we now have two view variables, one for hierarchical list, one for egalitarian, and that makes me wonder, well, what happened to individualist? Where did it go? I am not going to get into the weeds too much on this right now, but here's what I will tell you. When you have a categorical explanatory variable and you early on indicate that to R, which we did when we created factors way back here at the beginning, what R will do is it will create, when you're dealing with this categorical variable, it will create so-called dummy variables. And those dummy variables simply indicate group membership. It only takes two dummy variables to indicate three different categories. Now, how is that? How might it be that only two dummy variables indicate three categories? Well, let me show you. Let's suppose that I want to create a dummy variable, and I think I'll do it right here in our notebook. Let's suppose I want to create a dummy variable for hierarchical list. I'll just call it H. And now let's think of what the values of that variable can be. The values of that variable could be a 1 if you are in that group and a 0 if you are not in that group. And that indeed is how dummy variables look. Where do we see these dummy variables? We don't. They're behind the scenes. Up here when we created a factor, when we created that factor, we were saying to R, hey, this is a categorical variable. So when we ran the regression model here, it said, I have a categorical variable view. It has three categories. I need to create two dummy variables. So it created one dummy variable that was for hierarchical list, in which everyone that was in hierarchical list got a 1, everyone else got a 0. And then it created one for egalitarian, and it said, if you're an egalitarian, then you're going to get a 1 for being an egalitarian, but a 0 for the first level, because the first level was hierarchical list. So you have here a 1, 0 for hierarchical list and a 0, 1 for egalitarian. Everyone who is in egalitarian gets a 1. Everyone who is not gets a 0. Everyone up here on this first variable who is in hierarchical list gets a 1. Everyone on the second variable who was in hierarchical list gets a 0, but if they're in egalitarian, they get a 1. So in other words, two variables are created, indicated by my two columns here. My two columns indicate the values. Now, I'm not putting all 225 observations here. I'm just showing you for one person who is in hierarchical list that they would get a 1, 0, and for one person in egalitarian, they would get a 0, 1. Now, you might ask, what about individualist? Well, imagine if someone got a 0, 0. That means that not only are they not in hierarchical list, so if on the first variable they got a 0, so let's create it like this, individualist. The first variable they got a 0, why? Because they're not in hierarchical list. The second variable they got a 0, why? Because they're not egalitarian. If they're not hierarchical list or egalitarian, they must be individualist. So R only needed to create two dummy variables. There's only two columns here. And those two dummy variables are all that's needed in order to indicate three groups. So here's hierarchical list, 1, 0. Here's egalitarian, 0, 1. And individualist is 0, 0. Well, individualist actually does appear here. If you're getting 0, 0, you're at the intercept. You're 0 on everything. So you're right at the intercept, and there it is. So what does that 38.96 mean for our coefficient? If we go back up here and look at the mean for individualist, 38.96. If we come down here and say, okay, well, then what is this minus 2.037? Well, remember, every model has the intercept in it. And so if you take the intercept that's already in it, and now you happen to be a 1 on that first variable, so your hierarchical list, but a 0 on the second one, then you're not going to have this one in here with egalitarian, but you will have this one in here. So we will end up with 38.96 minus 2. So that's roughly about 39 minus 2, or 37. Let's go back up here to the means and look at that. The hierarchical list is about 37. So what this first intercept is the mean for the individualist, and what this minus 2 is how much you go beneath the individualist mean if you're a hierarchical list. Similarly, if you're an egalitarian, the hierarchical list is going to be zeroed out because you're going to get a 0 on that first variable representing hierarchical list, but you'll get a 1 for representing egalitarian, and so it will be about 39 minus 14, which would be about 25. Going back and looking at the mean for egalitarian, it's about 25. The first of the values here was automatically chosen by R to be the baseline. So this is really the baseline which everything else is compared to. So in the model, this establishes the baseline, and it's the mean of the individualist group. The other estimates then tell us how far we move away from the individualist group when we're in these other groups, first hierarchical list and then egalitarian. And if you think of this in terms of what the regression model would look like, we would have 38.96 plus, or minus rather, 2.04, I'll just round, times the hierarchical list minus 14.0 times the egalitarian. And this would give us our response variable, which is our risk score. And let's do this as a hat because this is an estimation. So our risk estimate is going to be this equation. Here it is. So I'm showing you this equation here. So how does this work? Well, if you're an individualist, what do you get for H? 0. What do you get for E? 0. So your predicted value is 38.96, the mean of the individualist. If you are a hierarchist, what do you get for our hierarchicalist? What do you get for the H? You get a 1. What do you get for E? You get a 0. And so what do you have? 38.96 minus 2.04, which is the mean for the hierarchicalist. And what about if you're egalitarian? You get a 0 for H, a 1 for E, so it's 38.96 minus 14, and that's the predicted value, the mean for the egalitarian. So that's how these work. Notice that there is going to be a degree of freedom for this coefficient. There's going to be a degree of freedom for this one. We learned when we were working with multiple regression with quantitative explanatory variables that for every quantitative variable we put in, that was 1 degree of freedom, and it was 1 degree of freedom that was subtracted out of our residual. Well, here it's going to be the number of groups minus 1. Why? Because that's how many dummy variables you need. That's how many variables are going to be put in the equation for a single categorical variable. It's going to be the number of levels of the categorical variable minus 1. One more point while we're at this. You might have asked the question, when we have these means here, these means could be anywhere. How do you think of this as fitting a straight line through those means? How could we do that? Well, think about it. If you're going to be in egalitarian, you're going to get a 0 on hierarchicalist, so there's only 2 values of interest, the minus 14 and the 38.96, and I would challenge you to think, if you only have 2 predicted values and you need to plot a linear model, you can plot a line right through those predicted values. Same with if we zero out egalitarian and have hierarchicalist. So even though it's a categorical variable, we're actually thinking of it in terms of our predicted values as being on a line. So that's what we have here so far for these coefficients. And then we also can look down here at our r squared. Remember what r squared is. R squared tells us the total sums of squares that can be accounted for by our model. Well, what is the total sums of squares here? It would be the total deviation about the grand mean, as it always is. The sums of squares total is the deviations about the grand mean, all squared and all summed up. We would have 225 of those because we have 225 observations. If we then wanted to know how much of the sums of squares we could explain, the answer is we can explain about 5% of those sums of squares with our model. If we explained 0%, that would tell me that all these predicted means are right smack on the grand mean, that there are no differences. The bigger this multiple r squared becomes, the further away these means are going to become from each other relative to the residuals, because they have a part in this too. Remember that we need to partition the sums of squares total into 2 parts. The part that's explained, which you can see as a separation of each of these group means from the grand mean, and the part that's not explained, which we can see as deviation of those points from their group means, from their predicted values. So that's what the multiple R squared is there. And we have a p-value telling us that it's small enough to be able to say that it's stable. That means that if we were to draw another sample of, say, 225 folk, we would expect that the R squared would still account for something, meaning that there are differences in the groups, even in the larger population, or even if we do repeated sampling. So the model does suggest to us that there are differences. The estimates of the differences can be seen right here. The hierarchical list is 2 different from individualist, and the egalitarian is 14 different from individualist. One final thing before I end this video and go on to the next one. You might look at these p-values and say, wait a minute here, do we have one coefficient that needs to be kicked out because it's a high p-value, 0.65, and another one that doesn't? Well, first of all, we should never kick out coefficients just on the basis of their p-value. We should start with theory. But second, because we're dealing with categorical variables here, think about what that is a p-value for. It's a p-value for this coefficient that is comparing hierarchical list to individualist. So the reason that it's big isn't an indication we need to kick it out. It's an indication that there may not be much difference between hierarchicalist and individualist. And you look up here and see, in fact, that is the case. There's not much difference. By contrast, the p-value is small here for egalitarian because it's being compared to individualist. And when we look, we see individualist and egalitarian. There's quite a bit of difference. So be careful with those p-values, because if we had reordered the variables so that there was a different baseline than individualist, then we would have gotten different results. So for instance, let's say that egalitarian had been the first one in our data set, and so that it was the baseline. Well, we would have had quite a bit of difference from egalitarian for both hierarchicalist and individualist, and the p-values would both be small. So the p-values really depend upon the ordering of things here. So I don't want to pay a lot of attention to that at the moment, because we remember when I talked about research questions, we also talked about we could have specific questions. That's when we'll start looking at, okay, now suppose I compare hierarchicalist to individualist. How do I do that? What about if I want to compare egalitarian to individualist? How do I do that? And these p-values are hinting to us that maybe we won't find a difference between hierarchicalist and individualist, but we probably will between egalitarian and individualist. And I should have said it differently. I shouldn't have said maybe we'll find a difference, because we did find a difference. Here are the means back here. They're all different from one another. So what we mean is maybe we have a suggestion here that the difference is not large enough relative to the noise, the residual going on around it. Maybe it's not large enough to be able to make an inference that that will be stable across different samples and the population. So that's what those p-values are hinting at us right now. Do we actually typically write a regression formula like this in this context? No, we don't. This is, again, a learning point. You won't see me do this when I'm creating my report, because what we typically do is we look at differences of the means, because the means are the predicted values. So we just see how much difference. So we are looking at those coefficients, but we can do it in the context of simply looking back here at our means, right here, and looking at the differences of those means. Okay. Now, we still have something that we need to talk about, and that is taking that multiple R squared and talking about how we obtain that from a partitioning of the sums of squares. So I'll do that in the next video.